Right, okay, so I wonder if we've started streaming yet. I'll hit the refresh button, should I? And click on live, viewing live. Okay, so we are live, and this is all going to be done completely live. And actually what I'm going to be doing is I'm going to be looking at the Mandelbrot set, and you can see here that I've browsed through a couple of these Mandelbrot sets URLs, and there's a whole bunch of videos as well. So but the difference between all of the videos down here and this one is I'm just going to do it live coding from the fact that haven't looked at this for ages and ages. So it's just completely like out of the box effectively. I've got to remind myself what Mandelbrot is, and I kind of like had a little browse over here in the Real Python, so that's one of the websites, and it's got kind of like a tutorial. I sort of like had a 10-minute look, and I wasn't I like the way they've explained it very well on this website, but I was looking for some code that looked quite easily replicatable, and this looks not too bad. I think I might be able to get some working code out of it. But ultimately, we're going to create something like this, the thumbprint of God, according to mathematicians, which is the Mandelbrot set. And we might even discuss some mathematics on what it was on. And it's actually inspired by a little bit of a video, well, it's like a 2-hour video of something that I've seen before that kind of like just talked about the first beginnings of the Mandelbrot set and sort of like what it does. And the mathematics of it is very, very interesting. So like you're encouraged to go and have a look at that. And also just on that note, and I did actually have it there somewhere. So, and actually while I'm doing this, I will also do a share. So I'm just going to hit the share button and copy that, and let's try and share on Twitter if we can, for the sake of it. Post. So something there, maybe some people will join the actual video as well, so we'll see on that. But yeah, this is all completely live. This is first time, so if there's ums and ahs, you're going to have to excuse the ums and ahs. And yeah, let's just crack on with it then, shall we? So I'm just going to like, you can see me, I haven't preset anything up. This is all completely like live. So I guess one thing to say is, it's only actually, I thought it was older than a year old, but okay, Python programming book, because I did write about the Mandelbrot set as one of the examples in this Python programming book that I wrote, which is called Top of the Stack, to get yourself to top of Stack Overflow. And yeah, how to improve your ranking and become a better Python programmer and a lateral thinker. Learn core concepts. I wonder if I copied that from somewhere else. Learn core concepts and the new practices of problem solving. Harness the immense community knowledge. And actually, interestingly, I'm literally just doing that in this video. Harness the immense community knowledge whilst challenging errors with expertise. Okay, I'm not going to challenge any error. Well, I might challenge errors, but I'm certainly harnessing this large community knowledge that we're talking about. And in particular, like when I go back here, if I hit the back button, like, you know, along with a number of the other major languages, Python is a really major language. It's some 30 plus years old. It's got a huge amount of libraries and support features, so we've got that as well in there. We explore the common questions, some common questions that any coder will invariably encounter. Hopefully we might see some of this in the Mandelbrot set, written by scientists and programmers who rank in the top 1% of, okay, yeah, basically let's pass the book. Like it's taking some of the knowledge of some really, really smart people, so it harnesses that. But anyway, the point being that it does talk about the Mandelbrot set, so that's quite an interesting one, because I don't think I've done a video on something that I've written about previously. So, and it'd be really nice actually if it did get 5 stars, but only by one person, and it wasn't me. So it'd be nice if other people did get it. I might put the link in the bio. I think I always do put the link in the bio. But anyway, moving on from that, I was over here, and this was a real Python version, and it does talk about something that's quite nice. But I couldn't, like, it didn't look like I could lift the code and paste it straight into a text editor. And I use VS Code. You're going to see my VS Code. It's kind of like over there, so you'll see that in a second. But I only had to go down to the second link actually, and this one's called Coding Game. I've never seen this site before, but I click on it and take a look at the code. And actually, this is the one where I felt I could lift some code out of it, because although it didn't have the mathematic background, what it does have, apart from the Z0 equals 0, and I have to like recall what this means, and the Zn+1 equals Zn squared plus C, and we will go into this one, but this is one of my favorite types of things actually in all programming in any language, which is and this is one of the things that computers are immense at, which is we can find the next value given so we can find the Zn+1 value given the Znth value. So given the preceding number, we can find the next number, and this gives you all types of amazing different things that you can do with regards to programming. It's a huge variance in what you can do with this. I didn't even read all of this. I'm still unclear. I recommend watching. Great explanation from Dr. Holly Krieger from MIT. So there we go, a video there. Let's have a little look. Open link just to might as well reference the right person. YouTube video. I have actually watched.
So today I want to talk about the
I've watched this video a couple of times. There we go. I do remember some of it. She's actually quite good, really good in this. But I think even more so, the real Python one's quite good, and there's more simpler versions I might go through to try and explain it. But anyway, just as a real broad headline, I guess, and I might zoom into this control. I think it's controlling. Yeah, there we go. The Mandelbrot set is one of the most famous fractal. That should be famous fractals, I guess, and is very easy to draw. In this playground, you will learn how to plot this. And one of the reasons I actually did use this one, I could have used any of them. Well, actually, the main reason is I saw this piece of code that was much easier to lift. It's got an if a double underscore name equals double underscore main guard here. I might talk about that, because just in case novices have a look at this. Like, Python is one of the easiest languages, but this is kind of like an odd bin, shall we say, in the language. But it's got one function here called Mandelbrot, and the real Python codes I think also had one function. And then when I went down here, it's got a plot.py, which actually uses a technique that I haven't used before, because I normally revert to matplotlib, and I was actually thinking of using pygame, because I think in the book that I wrote that I use, I'm quite sure that I used pygame or matplotlib, but here it actually uses the pill module basically, and it imports the image and image draw, and it draws an image here, output.png, which is quite nice. Normally I do a matplotlib, and then from matplotlib I might export the plot that I've drawn, so I can sort of like visualize the plot and then export the plot that I've drawn. But here it actually does it straight out of the box, and I was like, okay, that's quite nice. I'll have a go at that. And that's quite cute in the sense that I'm presuming here that, well, not even presuming, but it's kind of like telling me image size. We're defining the size of the image, and it's 600 wide, so 600. I can actually draw on the screen as well. It's 600 pixels wide, so something like that. This is world's worst drawing, and it's 400 pixels high. So our screen. So I should actually draw it in screen language, because screens start from the top corner. So that's the height of it. Screens in computers, they normally start here, like this top corner, and so that's the origin, the 0, 0 coordinate, and here will be the 600. Ignore the baby writing, comma, 400 down the bottom over there. That's the bottom corner. So, and that's that little point over here. So that's basically what it's doing. It's drawing to this is drawing to that particular rectangle, and it's literally just, I imagine it's just doing one. We can see the nested for loops, a nice technique, easy to understand in most languages. But yeah, definitely go and look at nested for loops. Again, I talk about that in the book too, so definitely go and have a look at that. And that's pretty much it. The one difference between Mandelbrot and other coding and is that basically uses complex numbers, which isn't particularly difficult. It's a very simple and very, very well-known concept. And I did talk about complex numbers in a previous video, actually. I've got to remember which video that was, but there was a complex number video too. Let's close this over here. Right, and get my screen over there so I can see. But uses complex numbers. Complex numbers are handled very easily in Python. So I'm going to go to my VS Code, and I've left it completely open because I literally copied and pasted a whole bunch of this code. And this is the nice thing about, one of the nice things about Python. It's a relatively simple language. I'm going to use a very simple editor. I've created, like I was doing a test Stack Overflow file. I'm going to actually migrate all of this code. So what I'm literally going to do is, and all of this is just literally a copy and paste, and I bastardized the code a little bit just to get it in a working format. And what I'm going to do is get it working in a much nicer way than, so I'm going to break it down into functions rather than just having it as a low-level script. So, and just to show, I guess I should do an alt tab really. All of this here was just, or where is it? Yeah, all of this here up to this max iteration is just, in fact, I didn't use this part here, this if name equals main, because that's only used if this is the main piece of the code. So I was like, well, the main piece of the code is actually in this second file here. So there's two files, this mandelbrot.py and this, which is this Mandelbrot function, and then this piece of code over here. And I'm not even going to write this as a second function, as a second module. So that I'm not going to create two Python modules. I'm just going to create one Python module and put my functions into it. So I've copied all of this all the way down to the bottom. And the one bit I did do was I mucked around a tiny bit just to make sure that my output file, wherever it was, that I could find where it goes, and I'll talk about that maybe as well. So I modified only the last few lines of it, and where this was called, this from Mandelbrot, import Mandelbrot and max iter, which is from this file over here, where that is all called, I effectively delete that out and literally just dump this whole piece of code into the top basically. So I remove line 2 and I paste it in. So I've kind of like got this sort of like working here. But what I'm going to do to make it nice and clean and show you how this all works is I'm going to create a completely new file. I could even copy and paste all of the code, but I might, like the chunks of code. Well, I might do that. I wonder. So inside here, I've navigated to a folder that I call physics. I should probably really call this mathematics, but I've got a mathematics file inside of my physics folder, and I'm kind of like keeping that like that at the moment because I've already got like loads and loads of files already on my system. So I'm going to create a new folder here in my module. I'm going to do it this way just to make sure that it's safe. So new file actually, and I'm just going to call it mandelbrot.py. Hopefully that's sufficient. I'm going to hit clear over here. You can see that I've tested things. I'm going to hit clear. Over here, I'm going to zoom into the code. We can see my file here. And one thing that I'm going to do before I do that is just check that I've spelt it correctly. So, because it'd be an absolute disaster if I didn't, I always like to do a copy and a paste. So I'm just going to do a rename if I can. Rename. Just make sure. Yeah, there was no typos in there. Hit return. Fine. Perfectly good. So irrational.py. I wonder why I've used that for, what I've done with that. Okay, so I'm going to get rid of that for now. I just want to keep this one file open. I will make that my first file in my little system. So there we go. It's an empty file in Python. I'm going to get rid of the sidebar now because it's not needed, and I'm going to do a control plus a few times, and I will make the terminal part at the bottom a little bit smaller so everyone can see what I'm doing. And I'm going to zoom in sufficiently that it's quite fat and chunky, and we can see quite religious about this, but this line over here, which is my 70 characters or 80 characters, 79 characters of allowable width in Python to be part of the Zn of Python. It's become habitual. I don't know why, but it's quite good for screens actually. I think I might be able to get one more zoom in. Control plus. Let's have a look. No, it just zooms out the end, so I'll do one and negative there. And I will actually, just for the sake of it, I'm going to replicate the whole thing so that we can see that working. So the first bit that I'm going to do is take all of this code. And this is the thing about it. And if I wasn't taking it from this website, I'd take it from another site, or I'd take it from GitHub or somewhere else. And like, there's so many variants. And because the community is so big that you get to do this with Python. So I'm just going to do copy over there and Alt Tab and paste all of the code over here. Now, this is what I was talking about earlier. We don't know what this code does at the moment. We're just taking it as given that this does something. But what I do know is I've got an im.save, and this basically what it tells us here, saves this image under the given file name. If no format specified, the format to use is to tell. Okay, but anyway, it's a PNG file, which is fine. But it's just going to save this output.png, but I don't necessarily know where it's running. So that's kind of like the key, is I want to specify like a full unambiguous file name so that I get the whole path of the folder. And if I wonder if I've got something like this over here, we can sort of like see that I want to get this whole path of the folder. And my one's actually going to go down now to physics, so I would have had to amend my code anyway. And in fact, I want to print the final thing in the assets folder, so we'll get that done too. So I might put in a tiny piece of background music, which is what I normally do, and I forgot to do that. So let's get some background music going as well. Dum 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 dum. Ask me later, get some prompts, and hit the play button. There we go. Makes it more enjoyable for everyone, assuming that you can hear it. But yeah, I'm going to have to get this whole path. Now, I've used one of the large language models, my latest version of the large language models. I've used something called Corcel, it's my newest version of it. And I've kind of like typed in here, get the code. Like I've done some prompt engineering, as it's called, and I've done path of current file in Python, right? That always kind of like gets me very close to what I want, and it gets me there's different ways of doing it. I can use the OS module in Python to do this, and this gives me the path of the actual file itself. But what I wanted to do was get the folder containing the current file, and so it did a good job to start with. But I wanted to get the folder, so I wrote get the folder, and it's written here to get the directory containing the current file path. You have to do this. So I did something like this in my previous piece of code, in the previous code, which is that in the code that I had, I just called it path, and you can see the squiggly underscores. OS is not defined. That's because I haven't imported OS. So the first thing I'll do is import another habit, which is always import the built-in modules first. But even more so than importing the built-in modules first, I import them in order of size, and OS is only 2 characters long. So that's good. So now that should work. That gets me the absolute path. Now, I comment this one out because I don't want to do an image.save in the wrong path until I'm sure of where it is. But now I'm going to actually be doing nested file folders as well. And I will scroll down and do a little cheat in a way as it was, but I use an os.path.join, so I might just take all of this anyway. But I'm going to have to nest it in some subfolders, because now not only have we moved it, but we've moved it to, I wonder if I could see all the breadcrumbs here. Should be able to. Width, height, so. Oh, here, if I hover over it, it'll do it like that. So I've got to go to the My Drive. So I'll get all the way to where the physics is, but then there was some nested folders in there. So I've got this bit here, but I'm going to have to put another comma here, because what we showed earlier was that there was actually an assets folder. So, and I want to dump it into this assets folder, just because it's where all of my images go. So hopefully it'll be easier to find, maybe, it may or may not be. And I might even call it something. So I'm going to put this in the assets folder. Again, making sure that we spell it correctly. So, you know, really I should, if I can click on it, this is actually the assets folder, and avoid any typos. So the master of copy and pasting. And so the first thing that I've done here is get the directory name of the file of the folder, and the next thing is I go to subfolders, and you can sort of like do this os.path.join is probably the simplest or best way to join paths, because then you don't have to worry about forward slashes and backslashes and so forth. So that should be the full thing. But just to check that it works, I'm going to print path like that, and hopefully, although it's going to run all of the other stuff, at least we'll see if it threw an error. Actually, it's not going to do anything because we're not going to do the save, but we can run our piece of code, and hopefully it's just going to say the path name. No, there we go. First error, but of course this error is going to occur. So I'll hit stop over there for a second, which is perfectly fine. I've got to get this import Mandelbrot away because I've got to replace it with this max iterations. So let me just go back to that piece of code and go to the mandelbrot.py, and I'm going to nick all of this piece of code over there. So I don't have to import max iter, and I don't have to import Mandelbrot because they're going to be predefined now. And just for now, I can stick them. I'm literally just going to dump them up here at the top, which means that I can comment this out now. I don't need to rely on it. So I don't need to import it from another module, from another file somewhere else in the system. I've just got the Mandelbrot now defined. So when I call it later on somewhere, and that was the thing about it, wherever it is, but I think we'll call it, here we go, Mandelbrot. When I do call it, it's now defined, and it's defined up here because this function has been created at the top. So I should be able to just run the test now, and hopefully it'll run through. It won't do anything because we haven't actually done anything with the image, but we're just testing the path name at least. So it's doing its computations in this time. I presume it's doing some computations. A bit slower than I expected, actually, because in my test it was faster, but here we go, and we can see that it goes to this assets folder, this Python physics assets. Output.png is what it would have been called, but I'm not going to call it output.png anymore. I will call it, copy that, I will call it Mandelbrot.png because it's easy to find, and I'm going to do an underscore OO just in case I do some other files, like, and I'll call them 0102 or something like that. I might have a naming convention, who knows. So I don't need this path anymore, although I think again on this thing that I did here, I did do that because it's quite nice just to remind ourselves of where it's saved. So I'll take that little piece of code and paste it over there. And now it says print the file is saved here, and it tells me where the file is saved on a new line, which is quite useful and helpful. So that's basically it, actually. And I could actually run this code as it was, but I might clean it up a little bit. So I can remove this now. And there's no if name equals main guard here, so the code is just going to literally run. And the way that Python runs, like I'll go through this like multiple times to be clear on it. The way that Python runs, just like all other, well, okay, it's maybe, I don't know if it's unique to Python, but it runs sequentially like this, so everything runs in order. And the purpose of the if name equals main guard is just to make sure, or to, like, Python doesn't have hoisting, it runs code sequentially line by line. So first it's going to read this this module, which is a built-in module. Then it's going to read this module here, which is an imported module, which I think I would have had to do pip install pill. If I actually do from pill import image, just to show everyone over here, if I did a from pill, like, I'm sure that will be sufficient because it'll go to the read the docs. I wonder if there's fork documentation from pill, the handbook installation. There we go. And or pip pillow might be a better way of doing it. There we go. I've been to this site before, but everything, or the most common way of installing things in Python, is to go to the PyPy website, where we can see all of the different modules. And so this is the Python package manager, and I could do Python -n pip install pillow. So I should like copy that, and I could run that. So here I do that, and then paste all of this piece of code in here, and that's just going to install pip install pillow. You could just do pip install pillow. It's much better to do Python -n because that ensures that this module is installed to the current working version of Python, which is 3.12 in my particular case over here. And that would just pip install it. I've already got it installed, so I don't need to run that. It would take about, I don't know, a minute to sort of like run through and do its installation, and then you can use it. So this is an imported, this is a user-defined or a built-in module, and this is an imported module and an installed module. And that's basically it. So it'd read these two lines of code, then it would read this here, and capitals in Python, because by convention, capitals in Python indicates a constant, so something's going to remain, because there's no such thing as a constant in Python. You can overwrite, but the convention is capitals and they get highlighted in a different color. And one thing I might say is that max iterations over here should belong, I guess, so like X. I'm going to sort of paste it over here. Now we can see, I wonder actually, max iterations still, this is a global variable. Global at the moment. Why is it global? Because it's called here inside of this function, it's seen here. So if I did call Mandelbrot C, it wouldn't know what max iter actually is, but because it's a global variable, it will inherit from the global. Now, I don't want to use globals. I'm going to put this all into functions, but so maybe I'll do a test anyway. But everything outside, so everything outside of this function, or everything, you know, the whole code basically is in the global namespace. Some people might work there. Certainly for big projects, that would be poor practice. So I'm going to move it into like local functions. So everything's got its own local namespace. Now, the way of doing this, or maybe I'll actually do a run just to show that this actually works. So I will do this, right, and I will hit F5 to run it, F5 to actually run the code. Oh, how about that? Hit stop quickly. Wonder if I can break it in time. So over here, I'll paste that in there because I want to actually save whatever the path was. And so the full file name Mandelbrot_oo.png, not output.png. So let's just try and run this code now. So just as well, hopefully it gets the end of the code. Right, so it says file is saved here, and we can sort of like go and have a look at the file. And one way of going to have a look at the file is actually in the Explorer. So I've got to go to the assets folder, it'll be in there. and usually it dumps it at the end. Nope, it's done it in alphabetical order. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So it's actually done in alphabetical order now, which is nice. And that's the Mandelbrot. So we know that it's working. So now I've got to fix it into a much more working way, and we can sort of like play around with it. But that's really nice because what are we here? 30 minutes. The reality is it could be a hell of a lot faster. I got this working in like 3 or 4 minutes. Within like 5 or 10 minutes, you can get something working relatively fast in Python. So that's one of the very nice things about this language and why people tend to use it a lot. So we've got this file that's there, but now I'm going to, in real time, attempt to tidy this up. And I have something here, I call it template. And this is quite nice feature of Visual Studio Code, which is that it lets you do snippets. And if I do this snippet here, so this main template over here, it does this, and it's created this little block of code here where I can put my imports, and then I've got this main guard idiom, which is this double underscore name, double equals double underscore main. And that's basically saying if this module is the main module, so if this is the module that's being run, then execute this piece of code. And this is quite a common pattern in Python. So the piece of code that will execute now is main over here. So now I can put everything in the main module, and I can kind of like modularize all of the code. So that's what we're going to attempt to do. But I will have to be careful in a sense, because this global, well, I won't have all of these global variables, and global variables, generally speaking, I think they're frowned upon, also like a poor practice. So you're welcome to put your comments on that if you think that's not the case. So we've got our Mandelbrot function, and then we'll create another function inside of them. We've got our imports, by the way. So we'll take this X, I'm going to take that and put that right at the top, because that's where our imports go. There we go. So that's nice and tidy. We've got one function here, Mandelbrot. And the reason I do this is I like the hoisting. Well, I call it hoisting. In other languages, things are hoisted, but the functions, everything gets read, and then this main piece of code is only run when we get to the end. So this name equals main guard idiom is always the last piece of code, basically. So everything's read, so all of the functions exist in memory, and all of the globals and everything, if they were there, they all exist in memory, but they only get run when we hit the end of the code. So they get run in any sequence that we like, which is quite nice. So I can take this main piece of code, I'll do that as well, and I'll dump that at the top, because we want our main piece of code to be the function that calls all of the other functions. So that's quite cute. We can put that at the top of the, so this is the main entry point for the code. Now we haven't done anything yet in the code as such, but all of this stuff is like making globals and doing the for loop. So I'm going to call something like, we've defined our Mandelbrot, but we can do something like define a function and like run underscore Mandelbrot. Again, I'm going to steal because there we go, run Mandelbrot. We could have a function for a docstring for our function. So let's just say this runs the Mandelbrot code, right? Now, and we're just going to call that from the main module. Now you might say, well, why are you doing that? It's not necessary, because you've only got like one function. Like it's too short to do that. But if this code was ever to build out, and if I was to add more functions, I can control everything from the main module. So that's the reason. So I can just call my run Mandelbrot, and we can see how nice it is, because when I hover over it, this is the this runs, I'm going to change it, this runs the main Mandelbrot code. So it's kind of like telling me, so I can sort of like organize my code into chunks quite nicely. Now, this was a global, so I've got to pass it into my function now. I might just take all of this code at this point, X, like the whole damn lot, and paste all of this. The one thing about Python actually is the indentation, really annoying, is that you gotta make sure that your indentation is correct, because unlike other languages, Python needs indentation to define its functions, and the convention is 4 spaces. So we've got our 4 spaces, and that's what it looks like now. This is no longer a global, it's a max iter. But the thing that's going to happen is we're going to call our Mandelbrot, and it's going to go and try to run the Mandelbrot. So where is it? It's going to go, well, it's down below, so it's going to go to this Mandelbrot here, and it's, look, we can already see this max iter is not defined. So we're now going to have to pass in a max iter. So we're going to have to make this not a, it's not going to be a global anymore. I could keep it as like bold, but I'll actually do max underscore max iter, and nicer than that, as part of the tidying up, that's max iter. I can also type hint that this is an integer, because I believe it is an integer. It says of type integer. C, I think C is of type complex, but C is of type, I'm quite sure C is of type complex. We can read the definitions of it. So type complex. I think that will work. Not that we needed that, but if we're going and doing our type hinting, that's quite nice. This is the function signature now. C is complex. The max iter for the maximum number of iterations presumably is an integer, and our function returns back an integer. So we've got all of this nice stuff built in for us, really, really convenient. Now, when I call that, I've got Mandelbrot here, and it needs a second argument now, which is over here, max iter. And one thing that I might do is, this max iter was 80, is I can default this to 80, so, which is an integer, and it's actually equal to 80. So we set it to 80, which now means that we don't have to necessarily call the max iter anymore. So we don't have to call it here because it automatically defaults to 80. But it looks like it's being used elsewhere as well. And so if I double click on this, I can see that it gets used down here, this max iter. I might set that in here anyway, so I will go max underscore iter equals 80 like that. And I will pass in the max iter here, so max iter equals max. I wonder if I could leave it as a constant at the top, if that's max underscore ITR. I think that's how it was initially, so I could leave it as it was, but then max iter equals max iter like that. Okay, so that should be fine now. So it would have defaulted to 80 if we didn't have this in, but now we can actually change it over here if we wanted to, but that's, I don't know, if we want to do it like that. But we can now go, I think we can go and test our code. I can see that this palette is, well, that's an empty array, but did it get used anywhere? I wonder if palette got used anywhere in the first place, because palette's not called anywhere. I can see that because it's a darker color. So Control F. Is palette used anywhere? No. So that looks like it can be removed. And presumably this code will still run now. Now, we can see from the breadcrumbs, which is this thing, not the breadcrumbs, the minimap. We can see our minimap over here. So on the right hand side, I'm talking about this little piece, we can sort of like see the structure of the code. And we can see that there's a little function over here. You can just about sort of like see it, it's tiny, but we can see the shape, the def. And then there's this big function over here, which is all of that block of code that we like copied and pasted. And that's our Mandelbrot function over here. That's our if name equals main guard over here. and our imports are all up the top over here. So we can see how we've kind of like modularized everything, and like our command unit, our name equals main, is basically this piece over here. So that's the if name equals main at the so that's our main entry point for the code. But this if name equals main only gets triggered when we are down here at the bottom of the code. So then this gets triggered, and then it starts calling all of the pieces that it needs to. In our particular case, it just calls this function, which then subsequently calls this function. But we can now do a lot more complicated stuff to like build it out if we wanted to. So that was the whole purpose of that. But because we've done a whole lot of this stuff, let's just test it out and run it and just see if it runs. And maybe I will make an O1 just to verify that the file's there, hit F5 and just see if we've broken it or not by doing those adjustments. I usually break things. This is all live, so I've got no idea if I break this or not. Seems to be going okay. Hey, save the file, and it's done it as Mandelbrot 01, and presumably we can go to the file manager system, and there we go. We've got a Mandelbrot underscore 01.png. Where did our Mandelbrot underscore 00 go? Hold on one sec. That's our Mandelbrot 01. Got to be careful with the file naming thing. That's the second time. No, that should be fine. File is saved here. It's a Mandelbrot 01. I just wonder where the Mandelbrot 00 went. Oh, there we go, right above it. So we've got Mandelbrot 00, Mandelbrot 01. I wonder if that was there before. I'll see that on the replay, but either way, it's just directly above it. So we've got our thing, and we can verify that it all works by clicking and opening it, and we didn't break any of the code, and now we've modularized it, put it into little functions. So I think we can possibly do better at this point as well, which is maybe do we don't need this palette, it never got used. Maybe there was a point for that palette. Image draw, we've got for loop, nested for loop. We kind of have to have a nested for loop. There might be vectorizing ways of doing this, but a nested for loop is relatively intuitive. And what it actually does is for x in range 0 to width, so it sort of like scans across the width bits like that. But for every x in this range, it then scans down the height, the y's, so it goes across the screen going from 0 to width, and width, I can't remember what it was it 400 or 600? I think it was 600 wide, so it starts at like 0 here and it goes 1 2 3 4 and ends at 600. But for every one of those items, indexes start at 0, by the way, so that'd be 600 minus 1, be 0 to 599, not 600, but just it will go down and do 400 of these as well. So again, 0 to, this time I'll get it right, 399. And so it's going to keep doing that. It's going to keep drawing these things downwards, and it's going to complete an entire image. That's basically what this nested for loop over here is actually doing. And inside of that, although I haven't read the code inside of it at the moment, I kind of understand this pattern. It's going to be drawing some colors of some kind. So convert the pixel coordinate to a complex number. So let's touch on complex numbers then, shall we? Complex number is basically made of a real part and an orthogonal part, or an imaginary part, which is just a square root of -1. It belongs on something called an organic diagram. If I was to plot it out, this would be our real number line. So the real numbers, which might look like the x-axis, very similar to the x-axis, and this one up here is the imaginary one. These are our imaginary numbers, but I don't like calling them imaginaries, so I'm going to do a double undo because they're not really imaginary. They're just multiples of the square root of -1, which are just numbers that if we call these real numbers, they're orthogonal to the real numbers. They're just numbers that don't lie on the real number line. So they're not real, which is why people might call them imaginary, but they're just perpendicular or orthogonal to the real number line. So, and they're all just multiples of the square root of -1. So 0, 1, 2, 3. So 1 times the square root of -1, 2 times the square root of -3 times the square root of -1. Quite often it's noted as I, the square root of -1. We like to give things symbols. So I for imaginary, or in computing, it's J is quite used quite often as well. But anyway, that's what a complex number is. Python handles complex numbers relatively well. Create a complex number from a real part and an optional imaginary part. So, and here it is. This is our real part. So the first argument is the real part, and the second argument is the imaginary part, which is the multiple of times by 1j over here, which is times by 1 times by the square root of -1. So that's pretty much basically it. So this whole piece here is our real part. So x plus width, it's sort of like moving across and scanning it from the end to the start and so forth. And this is our imaginary part over here. So those are the components of the complex number. Then we call our Mandelbrot computes the number of iterations. And then let's continue on that. Okay, some little beeps in the background, so I've closed all of that. Then the color depends on the maximum number of iterations. Yeah, we've set our max iterations to 80 and it does the coloring for us. So maybe if we do, I don't know, max iterations, we'll change it to 40, we might see a different numbering or something, like a different colorization. But finally, I think this is the piece de la resistance. It's this draw point, because you're going to draw a point, X and Y. So at the X and Y positions on our graph, that's X is going to be this thing, Y is going to be this thing, C is, so we've got our complex number here. We produce this Mandelbrot thing, it creates this number M, this Mandelbrot number, and from that it gets a color, and it's just color, which is the, I imagine that that's the red, green, and blue. This is going to be a tuple here that refers to the RGB value. I'm quite sure it's RGB, but well, it might not be in the PIL library. I think it might be BGR for some reason. I wonder if I still have that PIL library open. But I think that's the one oddity about PIL, but it was written so long ago that I think that's the way round that it was. Read the docs, PIL fork. Can't remember if they've got. Oh, there was a basic installation, Python -3, pip minus and so on there. So that was the basic installation right from the beginning. There's usually examples and stuff. I don't know where the examples are. Installation handbook reference about. Maybe if we go to the main bit, there we go. Warnings, image color, image module reference, I don't know. It gives us some examples anyway. I broadly speaking know how this works, but yeah, you could figure that out and you'd have to look that part up. That's not the main part of the reason why we're doing this. So that's basically it, and it's going to draw the colours. So what I might do is just to make our Mandelbrot 01 slightly different. I'm just going to, and here's the thing about it, I'm just going to muck around now with max iter. So I've changed it from 80 to 20, so now our two images might look different, and I'll run that little piece of code. I don't know what it's going to do. I'm imagining it's just doing it in grayscale again, but with like fewer zones, so maybe it'll be more blocky. And so that's run. We can go here and we can go to our Mandelbrot now, and this will be, so we're going to have the difference between Mandelbrot, wherever I should find it, if I there's Mandelbrot 00, which was our original image, and now I'll lock that in so we can compare them side by side, but this is Mandelbrot 01. So we can start doing straight away, like we can see the difference between them. There we go, like more, this one's much more finely tuned, and this one's much less finely tuned. So let's make, and this is the thing about doing this quite nicely like this, is we could go right down to like 3, right, and we'll rename our Mandelbrot to Mandelbrot 2 there, and I'll actually make that 2. I don't even know what this, well, I do kind of like know what it will do. It's going to make it more granularized as well, and maybe this kind of like highlights it quite nicely. If I run this again, I should say what Mandelbrot actually does. So I'll just run it again, and I will do it, and I'll write it over the image actually. But basically, if I can find it somewhere, so that's the 01. So to search for it around here. 02, there we go, the 02 version. Right, might have to zoom out. Okay, it hasn't done very much, like it's too ungranular. But let me just, while I've got this dark screen on, what I'll actually do is, I've got the drawing thing here, but basically it's something like this Z, or the next Z, so Zn plus 1. So this next value of Z is equal to the previous value of Z. Remember that Z is a complex number, so Z is complex. Right, which lies on this Argand diagram. We can plot it out in the Argand diagram. So it's this complex number somewhere here, which has got reals and the orthogonals, the imaginary numbers. So I'll use J as the square root of -1. And for any given Z, so Zn, for any given Zn that we've got, and Zn is denoted by a real, and so it's denoted by 2 parts, this real part and this imaginary component over here. So it's denoted by these 2 coordinates. So we're literally plotting it on this diagram. If we square this number, well, we know how to square things in brackets in general, and the trick with squaring complex numbers is that J times J is -1. So straight away, if we've got 2 imaginary numbers here, then the expansion of the brackets, that's going to turn into a negative number. So, and then plus C is the final piece of this, and that was that C there. But basically, this is its starting position, I believe. So now if we plot this point over here, and we call this point C, that our next value of n is Zn squared plus C. So this is actually Rz. So we square this value, and then C is some arbitrary complex number that we add onto it. So this is actually Z. Right. So we can get Rz(n plus 1, and I should do like so this is Rzn, and when we square this number, depending on where it lies, it will go to another point here on the diagram. That's actually what it does. I mean, it's much better images of that. But that will go there. And then when we square this number, so this will be Z1, it will go somewhere like over here. Now, it's either, the thing about this is what we discover, or what Mandelbrot discovered, not we, but what Mandelbrot discovered is that it's either stable or instable, and so it either shoots off to infinity and we get some point here and then some points further out. So it either shoots off to infinity, or it stays within a zone and sort of like keeps going round, and it forms this beautiful like little pattern that does that. But even more so is that the number of, we can count the number of loops, and that's what's the Mandelbrot thing is, he does, let's put this into categories and of how stable they are, like how many like iterations to guarantee that it like remains within a certain bounded zone and it doesn't fly out to infinity, and those ones will mark black and the other ones will mark like a lighter color and so forth. And that's the Mandelbrot set, the thumbprint of God, basically. So that's basically what it pretty much does. So that's my really crude baby mathematical explanation of it, but wholly accurate to a reasonable degree. So that's pretty much it. So we can muck around with that, but max iter 2 was no good. So let's do max iter equals 4 and we'll save it over. So F5. Let's just run that. I wonder if I can just hit a refresh or reopen this and do a reload. There we go, saved. Ah, there we go, and we've got the new Mandelbrot. So we can see like a cruder version. And we can now start doing things. So for example, we could have all of the args in here. And this is the thing about it. From the main module, we might want to just have the max iter or some args. So like our max iteration here, max iter in here, and so like pass it through and then stick this into a Python for loop over here. So like in our main function, do for I in range, something like this. Let's just start it at say 5 and go to 500, and in steps of say 10, I don't know, 50. So something like that. So then we'll do 5, 55, and so from, let's just start from 50, just say for example now, 50 to 500 in steps of, so it'll do like 10 things, and then we could do Mandelbrot I like that, and if we did pass this run Mandelbrot here, we could put I here like that, and max iter now will be equal to I, so something like that, and this will be part of our function now. We won't have to pass. We will now create, so 50, 100, like I think it goes 100, 150, 200, 250. It goes. I wonder if it goes all the way, if it's inclusive or not, but it'll do like 10 of these. And we can even, over here, and this is the nice piece about this, we can turn this into an F string, and we'll just call this Mandelbrot I. I don't really think we call it I now. We're using I. Max iter or I, because we've passed it in, and I is sort of like I is now the max iterations. So I is an integer as well. There we go. So we can sort of like start building and doing these new things. Now I think I will run this because I'm not going to create that many, but it will create like 10 Mandelbrots. Let's just do that. I don't know what happens with 500 if it's going to be really slow. And again, you know, an extra piece that we could do is we could use decorators, or we could do a timer function on the Mandelbrot to make sure. But you know, let's just do this and see what happens. I should have run maybe a little piece of code or print statements first saying which iteration is running, so something like print running loop. So that we can see which loop we're running. But anyway, actually, it does do something because it's actually telling us it saved it. So it's done Mandelbrot 50, now it's doing Mandelbrot 100. So it's actually doing it. That's quite nice. All the memory management is handled in Python, which is the other nice thing. I don't have to like disperse or remove memory, like, because it got reference counting. So that's all handled quite nicely in Python. We can see it's relatively slowish to do it. It'd be nice to have a timer function on it. I'll leave that as an exercise for the readers to add a timer function and put it as a decorator. An exercise for the viewers, should I say, not the readers, but the viewers. It's on 250, we're going up to 500, so I will persevere with it. I kind of like regret not putting the timer function on before, but that's how these things get built. So got it. Some comments here. What are you making? Someone's asked what am I making. A Mandelbrot set. Mandelbrot set. A little clap and a hello. So hello to you too. There we go. Quite nice to get some viewership from time to time. So we're at 350 now. It's definitely, I think it's slowing down because I was doing the whole. I know that it's slow. One reason that it's slow is because I'm running the YouTube, and so it's using up some of my CPU, and I can see my CPU here now has gone to sort of like max madness as it was. So I have to bear with that and live with it. I don't like seeing the CPU like that actually because it's going to start getting hot. But I fill my computer. It's not getting too hot, it's fine, it's handling it. So we're at 450. Oh, we've only got one more to go actually because it's just going to go to 500, I believe. It'll either go, yeah, I think it'll go to 500 on the nose then in that case. Again, I'm not really like, I have to always think about the edge cases, which is for eye in range. This range, it's got a start, it's got a stop, and then it's got a step. When I can't remember if it's inclusive or exclusive here. Does it say that? Start, stop. Yeah, it says inclusive here. So it starts with 50. And then to stop is exclusive. I would have thought it would have thrown out the... Oh, has it done it? It's actually run it. So it did throw out the 500. It finished at 450. So now we can go and see all of the Mandelbrots. So... And that was this is really simple. Like we can keep on doing this, like these things and building on it. We can get this, and this is what people just generally do. You can build these really, really amazing pieces of code. So just by starting from really humble foundations. So here's all of our Mandelbrots now, and this is Mandelbrot 100, 150. Can we see the? I don't know if on our image we get the granularity. But we could, I wonder if we can zoom in because the whole point of it, no, we don't. Well, the granularity isn't great. So escape back out and zoom or close it up there. So it's 200, 250. They all kind of like look the same at this resolution. Unfortunately, we can see these like sub Mandelbrots, these like little dots, which are more Mandelbrots and other things. But yeah, they all look the same. So I'd have to kind of like, we'd have to use a lot more granularity and maybe make the plotting area bigger and so forth. But we get the idea. It's quite nice. So I think that's basically it. I might sort of like leave it here. This is Mandelbrot in Python. It's a relatively simple version. It's me running it quickly. I've pulled something straight off of the web. Let's remove this piece here. And I've got it running relatively fast. We've got it printing out some Mandelbrot plots quite quickly. So it's a great thing for the user to have. And I will sign off with that. If you like this video, hit the thumbs up button, the like, the follow button, the subscribe button, and all the rest of them. And I guess even if you didn't like it, still hit the thumbs up button, the like button, the follow button, the subscribe button. I do know, so I will plug it. There you go. Python programming, top of the stack. Go get the book. That's quite nice. That'd be really helpful. And vote it with a 5-star as well. That'd be quite nice too. And that's pretty much it. Maybe I'll do some Bitcoin stuff for my next piece of magic, should we say? Bitcoin Moses. We'll get one of these. This is all written in Python, by the way. So I might do something on that at some point. And that's basically it. So Mandelbrot in Python. Thanks for watching.